Welcome to qnawire.
Hi, so for this type of compounds, for tetrahedral compounds, in order to have different isomers, what we need is that all of the four sides are not equivalent in between each other. So in general, when you have different ligands, you can have some isomerism in that case, but in this case, we have a bidentate isomer, right? So what this is going to look like is that, for example, one possible arrangement would be to have my bidentate compound like this, A and A. So you could go ahead and try to write down all of the possible configurations and see what is going to happen. So in this case, you can see that if you take any of the reflection points on the tetrahedral compound, you're going to have the same compound. Another method to verify this is by doing rotations in between the atoms on the bottom. So for example, if we rotate around this axis, and we're going to keep only this part of the compound constant, you're going to arrive to the following compounds. And because of the symmetry, they are all going to be the same, right? So first I'm going to write down the A's, and then we're going to see where they should be bonded. So this would generate this arrangement plus A interacting on the other side. Let me put it down in another color just to make it clear that it's a different bidentate ligand. We can go ahead and rotate it more once again. And all of them are going to be exactly the same compound. Okay. And we're going to have the connections over here like this. Remember that the one on the top is being kept constant, so we're just going towards the right on the bottom ones. Whoop, over here with an A. And if we rotate this again, we arrive to the initial configuration. So as you can see, we are done with all of the possible configurations that we have, right? The only one that would be left would be metal A, 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 and A. Sorry, never mind about that. We have actually solved for all the possible configurations. As you can see, they are all the same compound. So the correct answer is that we can only have one possible arrangement. Sorry, one possible isomer in this case. And that would be all. Thank you very much and have a good one.